Hi student, welcome to this new video where we will apply the Gauss Reduction algorithm to solve a system of linear equation and also to put matrices into their reduced row echelon form. Now, let's look at this first example. We are asked a question to put this matrix in its reduced row echelon form. Now, the first thing to do here as a solution, right, will be to identify your leading entry for the first row. So here it's gonna be 2, right? So and it needs to be 1. So I have to do row 2 divided by 2. And this will lead to 1, 2, 3, 4, 3, 6, 9, 10. Now then what I have to do next is to apply that the fact that we need to have 0 under and above the leading entry. So I need to have 0 here. So the best thing to do will be to replace row 2 by row 2 minus 3 row 1. Right? And this will lead to 1, 2, 3, 4, 0, 0, 0, minus 2. Right? Because if you do that, you will have 3 minus 3, 0. And then you will have 6 minus 2 times 3, 0. You have 9 minus 3 times 3, 0. And then you have 10 minus 4 times 3, which is minus 12. So 10 minus 12 will give minus 2. And here, what do? I also need, in the second row, I need that the leading entry should be 1. So I will replace the row 2 by row 2 divided by minus 2. And this will give 1, 2, 3, 4 over 0, 0, 0, and 1. Now, remember what we said, that for a matrix to be recognized as a reduced row echelon matrix, the leading and above and below the entry, the leading entry should be 0. So we need to have 0 over here. So I will do that. R1 will be replaced by R1 minus 4R2. So this will lead to 1, 2, 3, 0, 0, 0, 0, 1. So the reduced row echelon form of A is therefore this matrix. Okay, so this was just a revision to let you grasp and understand how to reduce a matrix to its reduced row echelon form. In the second example, we want to solve a system of linear equation we need to solve the system of linear equation using the Gauss reduction method. So the first thing to do here is to write this system under the matrix form, where A will be from the system 1, 1, 2 to 1, minus 1, minus 1, minus 1, 1, and then B will be 2, 0, 3, and of course X will be X, Y, X will be X, Y, Z, right? Now, once we have this, right? Once we have this, we need to put this into the augmented matrix form. So I have 1, 1, 2, 2, 1, minus 1, minus 1, minus 1, 1, dot, 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 2, 0, 3. So what do I see? I already have my leading entry here, which is 1, right? So the next thing to do is that I need 0 to be below 1. And to have that, I have to replace the second row, right, by the second row minus row 1. And then I need to do also that row 3 equals to row 3 minus 2 row 1, right, to have 0 below the leading entry on the first column. So I have 1, 0, 0, right, which is easy. I have 2 minus 1, and then I have minus 1, 0. I have minus 5, 3, dot, 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 2, minus 2, minus 1. Now, I hope you understand how we do get these values, right? So let's have a look on the second row together. So we do that row 2 is row 2 minus row 1. So I have 1 minus 1, which is 0. And then I take the second column of the second row. So I have that, I'll have 1 minus 2, which is minus 1, and then I will have minus 1 minus minus 1, which is 0. So now I also need the leading entry over here, and the leading entry should be 1. So I have to say that R2 equals to R2 times minus 1. Okay, so this will give me 1 0 0 2 1 minus 5 minus 1 0 3 2 2 minus 1. Okay, so now that I have this, now I have a leading entry here, I have another one here. So now I need to have 0 above and below the leading entry. So I need to have 0 here where there's 2 and 0 here where there's minus 5. And how do I do that? So the first thing to do here is to replace R3, right, by R3 minus 5 R2. That's first. And then secondly, I have to replace R1 by 1 minus 2 R2 to also have a 0 up there. Then this will give me 1 0 minus 1 0 1 0, and then this will give me 0 0 and 3 dot 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 dot. So here I will have 3. You see, in this third row, 0 0 3, because, and I will have that minus 5 yes, minus 5 minus minus 5 is 0, and then I will have that. Then here I will have it will give me 2, and then I will have 2, and then I have 9. Yes, because this will give me 10 minus 1. Yes. Okay, 9. So now from here, what do I do? I can divide R3 by 3. Right? So if I divide R3 by 3, this will lead to 1 0 minus 1 0 1 1 0 0 1 dot 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 2 2 3. And I need to have 0 here as well. So some 0 here, and I will do that R1 equals to R1 plus R3, and this will lead to 1 0 0 0 1 0 0 0 1 1 2 3. Now we can easily see, right? We can easily see from here, from the first and second and third row, that the solution of the system will be x equals to 1, y equals to 2, and z equals to 3. So you can see how from the system of linear equation given as this, we were able to identify the matrix and give its reduced row echelon form as this, and then from here it's easy to identify the value of the variable x, y, and z. Thank you very much.